So this is lesson 4.6. Go ahead and try the warm-up questions to review isosceles and equilateral triangle. Prep us for our lesson today over those concepts. All right, so 60 for each angle. Since it's equilateral, it's equiangular, and those are all 60. Every equilateral triangle is isosceles. Yes, true. And every isosceles triangle is equilateral. Well, no, false. Only two sides can be congruent, not all three. Right, so let's go ahead and take a look. Refresh in our brain, isosceles has two congruent sides called legs. And the angle formed by the legs is called the vertex angle up here. And the other two are called base angles. So in this diagram, the base angles would be angles 1 and 2. And its vertex here would be 3. So we're looking at this picture. All right, so isosceles, if these angles are congruent, then these sides are congruent. And the converse of isosceles, so if two triangles, or two angles of that bottom part of the triangle are congruent, then the opposite sides would be congruent. So that's the converse. All right, so let's go ahead and name two unmarked congruent angles here. So that would be angle BCA and angle A. And then two unmarked congruent sides, well, that would have to be BC here and BD, this one right here and this one right here, because these are marked but not these two when we know those angles. So BC congruent to BD. All right, so the next page we have equilateral that we're going to be looking at. So a triangle is equilateral if and only if it is equiangular. And then each of the equilateral triangles angles measure 60 degrees. So a lot of this is review, or should be review. So what should angle R be? If this is 5 and this is 5 and this is 60, then that would have to make each of these congruent because the sides here are congruent, and if they're congruent and that's 60, then those would have to be both be 60 degrees as well. So that would make this side, since it's an equiangular, that would make this side 5 centimeters, since it would make it equilateral as well. All right, then find the value of each variable. So if these two have tick marks, we can set them equal and we can solve. So 6y plus 3 is equal to 8y minus 5. And we would subtract 6y. So 3 is equal to 2y minus 5. Add 5. So 2y is equal to 8, which means y is 4. And then we want to figure out what x is. So looking at our angles, then we know that E, these are going to have to be these are equal, which means this is the vertex angle, so then that would have to make that and that equal for isosceles, so they'd all be equal, so they'd all be 60. So that means we can go ahead and put 4x minus 8 equal to 60. And solve. So 4x is equal to 68, which x is equal to 17. So looking down here at this next example, we know that if that's 140, then this right here is going to have to be 40 because of linear pair. And if these are both congruent, which they are, then we know that this side is 20, and then that would make this side 20 as well. So we could go ahead and say, since angle YXZ, the measure, is equal to 40, then XY is congruent to YZ by the converse of isosceles triangle. Okay, so going from the angles to the sides is that converse. All right, so down here, find F. Well, if that's 22 and these two sides are congruent, then these two angles are congruent. And we can go ahead and subtract 22 from 180. And that is going to give us 158 for these two congruent angles. So we're just going to split that in half. And that is going to give us 79. All right, so this one over here, these are going to be congruent. If those two sides are congruent, then the base. And we can set those equal and solve. So that is going to give us 2x equals to 44, which means x is equal to 22. So if we plugged that back in, because we want to find the measure of angle G, so we need to plug it back in. That's going to be 22 plus 44, which is 66 degrees. On the next page, this example at the top here, we're trying to find x. Well, all these sides are congruent, so all these angles are congruent, which means they all equal 60. So we can set that equal to 60 and solve. So 2x is equal to 28, and when we divide both sides by 2, we get x is equal to 14. On the next one, if they're all equal angular, they're all equal sides as well. So that means that these two are equal, so we can set those equal and solve. And so we get y minus 6 equals 12, add 6 to both sides, and y equals 18. All right, we've got our proof here. I'm going to kind of do a flowchart proof. So let's write out what we're starting with, our two kind of givens in two different little boxes here, and then we'll kind of go from there what we've got. So let's go ahead and put our two givens bisecting and then our congruent parts, and then we'll kind of make our way from there. So fill in your two boxes for givens, and then we'll go from there. All right, so here's my givens, and we're going to then go from bisecting to defining that, right? So if YW bisects the segment XZ, it's going to turn this congruent to this. So that's going to be XW is congruent to WZ. And the reason for that is definition of bisect or midpoint. Midpoint or bisect. Bisector. All right, so then we're going to go from this, let's mark this in our picture that XY is congruent to YZ. Mark that with two tick marks there, but that's not going to lead to anything else. So it's kind of its own separate thing here. So next, we are going to look for anything else we can use to prove these triangles congruent. So it looks like we need another side because we can't really get any angles. So this could be congruent to itself, and so that's YW, and that's reflexive. So now, with all three of these pieces, we can prove the triangles are congruent. So that's going to be triangle XYW congruent to triangle ZYW by side, side, side. And how do we then prove any other parts are congruent that correspond, like XYW and ZYW? Well, by CPCTC, we can prove and get to our last statement there. All right, this next one, we're going to have 6 steps, so go ahead and set it up. And we have both of our givens in step 1. So go ahead and have 6 steps and put both your givens in step 1. And then step 6 is what we're trying to prove. And then we'll go through that together. so statements, reasons. We're going to mark our picture as we go, and we need right. So statement 1, NO parallel MP angle N congruent to angle P. We need to mark that. So NO parallel to MP, and N and P are congruent. And that reason here is given. And this should be MN parallel to OP. Okay. So we need to prove our triangle's congruent, then we can use CP/CTC, and then we'll use another theorem after that, after CP/CTC, to get parallel lines, because we know to prove parallel, we know we're going to need converse, converse of something. All right, so we need to use probably CP/CTC, and then we're going to prove our triangles are congruent here. And then we'll go CP/CTC, then we'll get to our last thing. All right, so what else can we mark here in our picture? If we have parallel lines, we could mark alternate interior. So that could be marked to get some angles. So angle NOM is congruent to angle PMO by alternate interior. But again, you have to have parallel lines first, which we do. Then we could mark this one, this side, to itself by reflexive. MO congruent to MO by reflexive. And does that give us enough? An angle, side. Yes, that's enough. So we're going to put angle, side. And that's triangle MNO is congruent to triangle OPM. Now, we need something to help us get to these being congruent. So we need some angles, and then we can do our converse of whatever angles those are. So this angle right here is MNO, or NMO, there we go. And that is congruent to angle POM by CT/CTC, because we know it's part of the triangle that this one has to be congruent to that. But what kind of angles are those? Those are alternate interior that go alongside our two sides we're trying to prove parallel. So alternate interior angles, and the converse proves parallel.